I'm now working on number 22. I wanted to show y'all a real world example of how we can use factoring quadratics in order to find some information about a quadratic function, but in like a real world setting, okay? I'm on page 458, all right? So page 458, and this is number 22. This is the example about the whale. So we'll just read through it real quickly. It tells us that a whale jumps vertically from a pool at Ocean World. The function y equals negative 16x squared plus 32x models the height of a whale in feet above the surface of the water after x seconds. All right, so before we even go through parts A and B, I just want you to have a visual of what's going on, okay? So I am going to make a little graph of what's going on with the whale. Now, I'm not drawing the whale. Just, you don't want me to do that. On the x-axis, it told us that the x's stood for seconds. All right, so the x's stand for seconds. The x's are seconds. I know that this is 0 seconds right here. We'll see what other kind of time frame we need right here. And then it told us that the height, it's compared to the height of the whale in feet above the surface of the water. All right, so by the way, right here on the y-axis, this is 0. That's the height. I'm going to turn this way. This is height in feet, okay, above the surface of the water. All right, so if this is 0 feet right here above the surface of the water, then that is the top of the pool of water, I guess is how you would say it. And this whale is literally defying gravity and jumping up and out of the water, okay? So that's what's going on. So a couple of things. The function itself says y is equal to negative 16x squared plus 32x. Look at that negative sign right there. A is negative. What does that tell you? It tells you that the function opens down, okay? It opens down. So a couple of things that we're going to figure out starting with part A, all right? Part A wants to know what's the maximum height of the whale above the surface of the water. Well, let's think about this. If A is negative, that tells us that our quadratic is going to open down and we're going to have a max height. So in part A, what they want us to find is the vertex, all right? And let's think about that vertex. We have x comma y for the vertex. What do our x's stand for? I just wrote it right there. It's time. X is time. And what is y? Y is the height above the water. Okay? Height above the water. And the question is specifically wanting to know what is the maximum height of the whale above the surface of the water. So they're wanting us to figure out the y value of the vertex of the function. All right, so I'm going to walk you through these steps. To find the vertex, you need that vertex formula. That's negative b divided by 2a. All right, so we're going to plug in our values, right? So we know that a, let me list these out on the side here. A is negative 16, b is what, 3, and there is no constant term, so we know that c is 0. All right, so if b is 3, so I'm going to plug in negative 3 divided by 2 times, I'm such a silly goose, this should be 32. Oh my goodness, Miss Rath. There we go. I'm slipping, y'all. I'm slipping, but I caught myself. Okay, so I know y'all were out there shouting at me. It's 32. Negative 32. All right, so 2 times, what's a? Negative 16. All right, so we've got negative 32 divided by 2 times negative 16 is negative 32. Negative 32 divided by negative 32 gives us positive 1. Okay, so for our vertex, we know that the x value is 1. Now the x value is not exactly what we're looking for though. We're looking for the y value of the vertex. But this 1 means that since this is time and it's measured in seconds, it means that in 1 second after that whale jumps, he'll be at his max height, or she, okay? Will be at its max height, all right? Okay, so next thing we need to do is we need to plug in f of 1. All right, so we need to know where or how high is that whale after 1 second of jumping out the water. Okay, I'm just impressed that a whale can even jump out of the water because it's just massive. That's pretty incredible. I digress. Here we go. So f of 1, we got 1 squared is 1. 1 times negative 16 is negative 16. Plus 32 times 1 is 32. Okay? Negative 16 plus 32 gives us, what? 16. 16. And this is our y value of the vertex. And the y's, again, stand for height above the water. So that's 16 feet. OMG. So that whale is literally, after 1 second, 16 feet above the surface of the water. That's pretty impressive, y'all. That's, I mean, I don't know. I'm impressed. I'm impressed. Okay, so let's say that this is 1 second right here. And let's say that this right here is 16 feet. That means our vertex, or our max point, is right here at 1 second and 16 feet. So I'm just going to sketch this out on the graph a little bit just so you can get a visual of what's going on. So a second after that whale jumps out the water, 16 feet in the air. Pretty impressive, okay? All right, that's part A. Now let's take a look at part B. Let's take a look at part B. What does it say? It says, how long is the whale out of the water? Justify your answer. Well, how long is the whale out of the water? How long, that means time. It wants a unit of time, okay? That's another way of asking us, how long does it take for the whale to jump out of the water and end up back in the water? Okay, folks? It's wanting to know the x-intercepts. Okay? It's asking us for the x-intercepts. And we're going to get 2 x-intercepts when we solve, and we're going to talk about what those 2 different x-intercepts mean. Okay, so let's go back to our original function. We've got negative 16x squared plus 32x. I'm going to take away this y equals, and I'm going to set the whole thing equal to 0. Okay? We're going to set it equal to 0 so that we can factor and we can figure out our x-intercepts, or our zeros of the function. Okay? First thing, look for a GCF. A GCF. So I've got a negative 16 and I have a 32, right? Greatest common factor would be 16. And I'm actually going to factor out negative 16. It's going to make it a little bit easier for us as we're doing our factoring. So negative 16, look at that. Both terms have an x. So we're also going to factor out an x. Okay? What's left in the parentheses would be, what would that? 1x, right? Because negative 16x times x would give us negative 16x squared. And then plus, let's see, negative 16x times 2 would give us 32x. Oops, this needs to be what? Minus 2, right? Because a negative times negative gives us a positive, okay? And then we're going to set all that equal to 0. This is when you separate into the 2 equations. So I've got a negative 16x is equal to 0. I'm going to set that equal to 0, and I'm also going to set this negative x minus 2 equal to 0 as well. Let's solve them both for x. This is going to give us our x-intercepts. 0 divided by negative 16 gives us 0. I'm going to add 2 to both sides right here, and I get x is equal to 2. Folks, these are our 2 x-intercepts. All right? If it's an x-intercept, we know the y value is 0. So 0, 0 for the y, for that x-intercept, and then this one would be 2, 0. So let's go put those 2 points on our little graph that we made over here. 0, 0, and 2, 0. Let's see what that tells us. I've got an x-intercept here at 0, 0, and I have another one. Let's say if this is 1, then I'm going to put 2 right here. So I'm going to put another point right here, 2 at 2 and 0. So look, I've got the vertex, and then I've got the 2 x-intercepts. Watch what we can do. We can draw the sides of the parabola. Okay? Look at that. Isn't that neat? Okay, so what does that tell us? Like, what do the x-intercepts tell us? Well, it tells us that at 0 seconds, that whale was at a height of 0 feet above the water. Folks, this is right before he starts to jump, okay? So this is where the jump starts. I know after 1 second, the whale is at its maximum height of 16 feet above the water. And then I know at 2 seconds, that whale is now back in the water, okay? It did its jump. That entire jump lasted 2 seconds, and now the whale is back in the water. Isn't math amazing? I think it's pretty incredible. Now, we also know that quadratic, like if you type this thing in on Desmos, you would have parts of the quadratic that continue on like that, right? Below, into the negative numbers, like y values that are negative. So this would be below the water, correct? That would be below the water, which the whale can swim below the water, right? But we're not interested in those times, okay? We're just interested in the time when the whale is above the water. Okay? I hope that gave you a cool little perspective on how to do some of these quadratics in real world examples. We will definitely do more of these because I think they're fun and amazing, and yeah. All right, bye.